Okay, so there you have it, iron oxide, rust. See the rust? This is a piece of steel and it got wet. You can see the rust coming off of it. Okay? So making electrodes out of certain materials is very important when you perform electrolysis, okay? If you're going to use stainless steel and things like that, you got to remember that they do corrode, they will rust, okay? There's iron in stainless steel. Let me go through this book here real quick and show you right here. If you can go back and pause this and read it, it's going to tell you a little bit about iron. This is the element that kills stars. This is what smothers a star. So this is the element that's rusting out in your fuel cell. Okay, anytime you use stainless steel, you're leaching iron. It's right here on the table of elements. If you look at my table of elements here, see your hydrogen, oxygen, carbon. I'm using carbon electrodes. But if you look here at the iron, see this rusty horseshoe that they depict it with, number 26. So iron, this is what's happening with your electrolysis cell. See, I have my power supply here. Look, this one's on. And I'm not generating any rust because the electrodes in here, one side is stainless steel on my negative side, but then if you come over to my positive side here, it's made out of carbon fiber. Okay? So there's many different metals out there, whether you're using aluminum, tungsten. Just remember, stainless steel is a mixture of metal. And here's some silver coins, but they're not exactly silver. See, it's hard to get very pure coins. This is a mixture of copper and silver when they made it. See, even a penny, when you think it's a copper penny, you flip it over, see it's got zinc inside. So make sure you have very pure electrodes and pure metals. Know what you're working with in your electrolysis. Just wanted to point that in there. So if you build your hydrogen fuel cell or your oxyhydrogen fuel cell out of stainless steel, be prepared that the positive side is going to generate small amounts of rust as you go. And from what I understand, it's about 1 millimeter per year. So I mean, this thing's going to last you a very long time, but you will generate rust. It's an alloy, okay? It's a mixture of more than 2 or more metals. If you're not using pure carbon fiber like this, here's an entire list of metals that you could be using in your water fuel cell. So you can see there's a huge list of metals. And then depending on what you use on what side, positive or negative, determines the conductivity of your fuel cell, the resistance in ohms, and it also determines what pollutes the water, what's going to end up in your water. Is your water going to stay crystal clear? Or is your water going to have rust in it? See, so that's something you have to think about when you're using iron, when you're using stainless steel. So when you look in Job 38 here in the Bible, you know, Jesus, he walked on water. I'm just using it for my water fuel cell to make marshmallows right now. But if you look in here in the Bible, you'll see right here in Job 38, just like Stanley Myers was saying, if you come down here to the bottom, verse 22, you can clearly see that it says, "Hast thou entered into the treasures of the snow, or hast seen the treasures of the hail?" And I got that right here. Right here. This is the real treasure right here, guys. Right here. This is the real treasure. There's an endless amount of energy right here. You know, these are the treasures hidden. You know, I'm the richest man alive. You know, look at this. Endless treasure. There's more. There's much more. Enough to become kings yourselves. We'll get into that. But I just wanted to throw that in there. 3.83 amps. 440 watts this time. So there's a lot more power. See, it's a lot. More power gives you a larger flame. So you can clearly see how silver, gold, platinum, you know, all these different metals that are out there, silver is one of the best. Silver is one of the best conductors on the planet. Okay, so we'll go through this right here. I hope you can pause it and read it. Told you a little bit about silver. So silver is deadly to viruses and pathogens and things like that, so it's used widely in medical. A lot of people don't know that. So there it is on the table of elements. It's right above gold. There's gold, Au79, and then you have the silver atom. Okay, and silver is extremely important. And a lot of people are wearing jewelry and stuff because it's pretty, but they don't understand the scientific value of it. You know, if you had pure silver, you could make hydrogen fuel cells, oxyhydrogen fuel cells you couldn't imagine. You can make the best fuel cells in the world, depending on what metals you have. So the metals is extremely important. Okay, understanding what they're made of, what their electron shells look like. You know, understanding is your metal pure or not. You know, it's copper covered zinc. You know, silver mixed with copper. So it's hard to get very pure metals, but you can see why they're so important and why so many people have these expensive metals at the top and why they hold on to them. Because it's not because they're pretty and they walk around with it, it's what they do scientifically. I would love to get my hands on, you know, gold plates, silver plating. That would make the best fuel cell in the world because there'd be no resistance and the conductivity is incredible. Okay? So these electrons, they're quite happy sitting where they are. They don't really want to flow down this wire and go through your fuel cell. That's why we have to lower the conductivity of the water, or we're going to have really high voltage to overcome the water's dielect. Because water is a dielectric liquid. Get this thing going here. Now think about this. Ohm's law. Ohm's law is expressed in this equation right here. It's very simple, and you can get this online or just about out of any electrical book. You can see Ohm's symbol right here on my voltage meter. The Egyptians have that written on just about everything they own because they were able to cook, weld, drive, and fly on water. And they built these pyramids next to these huge rivers to have the access to the water to do that. But anyways, if you're wondering why your wires overheat, it's because the electrons resist. They resist the metal. They don't want to fly through here real easy. Copper, they'll go quick. But when they get to the stainless steel, it's like chug, 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 chug. It moves real slow. So yeah, it's important that you know about your wire and cable. You got to have the size wire to cover the current that you're going to carry. Too much current and you're going to overheat the wire. Even a sorry connection, if you have a really cheap bad connection right here and this bolt was just hanging off a little bit, all the heat's going to generate right there on the corner because electricity takes the path of least resistance. Least resistance. It's very, very easy stuff, guys. It's very simple. Here's the equation for electrical power. A lot of you guys already know this. I'm just throwing it in here so I can cover it to answer the question, you know, why do these things overheat? Why does my fuel cell overheat? So I'm producing that flame right here. About 3 amps, 330 watts going through there. And that's the electricity that's flowing through here. And the electrons were quite happy where they were, sitting right where they were. They did not want to move down there. And the heat becomes from the friction. The more you shove through there, the more friction you're going to get. So make sure you have wires and connections that are rated for the current and the amperage that you tend to put through them. Or otherwise it's going to heat up. If these wires were any thinner, they'd heat up. If these connections weren't any tighter and any better, they'd heat up. Now you want all the energy to transfer inside of your water fuel cell. So it really is all about resistance. The resistance in the wires, the resistance of the water wanting to resist the electricity, and about lowering that resistance using your electrolyte. So it's very important when to know how to raise and lower the resistance. Sometimes you want to raise it. You don't want the gas to be producing so fast. So always start with distilled water. That's a really good way to start out. That way you know there's nothing in the water. Then you can start using the lake water and the snow, ice, anything you want. any water source. That's the great thing about a wet cell. But remember this symbol because it's very important. It has a lot to do with splitting the water molecule, lowering the resistance. So the fuel cell, you can set it to adjust, so when you start it up here, when I go to start this water fuel cell, automatically I've lowered the resistance to where it starts out at 300 watts when I turn this thing on. It's been cold, it's been sitting for a long time now. It's only 81 degrees Fahrenheit in there right now. It's going to get a lot hotter than that. It'll go up to about 111 before I shut it down. If you take a look in here, you'll notice on a lot of their ships that are traveling on water with a water fuel cell reactor on board, you'll notice the ohm symbol is just about everywhere you look. I mean, he's literally standing in the middle of an ohm symbol. And you'll notice they put a lot of them upside down. People carrying reactors. Bird's feet, reactor on board. You can't miss this stuff. People filling water fuel cells, you know, setting electrolytes, you know. Some pictures, you know, don't need a whole lot of explaining. You're going to see water molecules in the background. It's all about resistance. So make sure you check out this book, Your Atomic Self, with Kurt Stager. Now, I've read this entire book, and it's kind of grim. It tells you what happens to you when you die, and how you're invisible elements that connect you to everything else in the universe. So everything you've ever loved or hated, you really are connected to it. We're all connected to each other. And I was thinking about when you die, you can't take none of these treasures with you. You know, these elements and things. Gold, silver, my jewels, my money. When I die, I can't take none of that with me. So I always remember what's important to do in life. You know, the battle against good and evil is the only battle. You gotta remember that. You see the light coming off the top of the pyramid there. Anyways, you gotta check out that book. You know, what is treasure? I have a knowledge of great treasures. You know, but what's important in life? You can't take none of this stuff with you when you go through the portal. You know, you're not going to take any of these material things with you. This is going to stay here with the next people. So you got to do what's important in life and what's right. This is a really good book. Check that out. I got my kilowatt here. So turn everything on. Gas going. Okay. Yeah, that pulsar's pretty bright, man. So you guys remember, don't